Assalamualaikum and hello everyone. We are third year student of Bachelor in Manufacturing Engineering at Universiti Teknikal Malaysia Melaka. We would like to present our product for Integrated Design Project that we call Expandable Delivery Bag.
Today, delivery bags are popular in delivery services, especially in food delivery services. However, delivery bags available in the market or provided by delivery companies are impractical in terms of space and do not have a rigid structure. As the picture shows, the bag could not be closed because there were too many items to fit into the bag. In a survey conducted to food delivery riders, 78% of them stated that food delivery bags provided by their employers were impractical and did not have firm structure. The problem statement in our study is delivery bag available in the market has limited space. Next, a weak frame of the bag can cause the shape of the bag to change. This happens when the bag is carried on a motorcycle and there is a force from the wind resistance that will damage the bag if the bag does not have a firm structure. There are three objectives in our study. First, to analyze the delivery bag problems between food riders and customer needs. Second, to plan and develop a delivery bags with expandable mechanism. And the last, to analyze and evaluate the function and durability of the bag.
Assalamualaikum. I want to explain about product description and analysis of the expandable delivery bag. First, I will start with product description. The expandable delivery bag consists of fabric, zipper, connector, hollow tube 1, 2 and 3, lock system, thermal bag and buckle. Next, I want to highlight the function of the expandable delivery bag. First, fabric and thermal bag act as insulation and help to maintain temperature, especially food items. Then, the zipper is used as an extender to expand the size of the fabric. After that, we use the buckle to tie the fabric. Connector 1, 2 is used to bind the frame of the bag. Hollow tube 1, 2 and 3 are used as a bag frame. And the last part is, we design the lock system as a mechanical tool to make it easier for the frame to be adjusted. This is an animation of how our product works. Our products can be expanded in a vertical direction. Then, this is an illustration of our bag in a small size. After that, in a medium size, one extender zip is open. Lastly, for the bigger size, both extender zip is open. So, how it works? The main innovation of our product is expandable. So, we designed this bag that can be expanded in 3 different sizes. We designed a lock system that can make the frame easy to adjust. The concept we use is from a press pan. For the analysis product, we already run the wind resistance and weak analysis. We apply this analysis through how this bag were used. Wind resistance analysis is made based on one illustration when using a motorcycle. Through the analysis, fixed support is placed under the bag and include wind resistance from the side of the bag. Then, the weight analysis is made based on when the bag is carried. So, the fixed support is placed on the front side and the force exerted on the bag is direct toward gravity. From the wind resistance analysis, we use an average speed of 80 km per hour. Using the drag force formula, the distributed load is 0.073 Newton per millimeter. Thus, the result of the analysis, the maximum and minimum shear stress is 7.798 megapascal and 6.697 times 10 the power of negative 9 megapascal. After that, The maximum and minimum displacement is 1.249 mm and 1.0 times 10 to the power of negative 30 mm. Lastly, through weight analysis, we use a mass of 13 kg. According to the calculated weight, the distributed load value is 0.00058 Newton. As a result of the weight analysis, the maximum and minimum value of shear stress is 7.699 times 10 to the power of negative 3 megapascal and 1.174 times 10 power of negative 8 megapascal. Finally, the maximum and minimum value of displacement are 1.61 times 10 power of negative 1 mm and 1.0 times 10 power of negative 30 mm.
So hi, I want to explain about process of expandable delivery bag. There are 4 processes of making delivery bag. Firstly is cutting process. For cutting process, we use sheet rod saw to cut the polypropylene plastic hollow tube for external part of the project. The process is used because it can cut polypropylene right through with a steady hand using sheet rod saw. This is more suitable process as it clean in finish. Next is drilling process. This process is used to drill supporting part to make a hole of the hollow tube by using a twist ring. The perimeter of drilling process from sizing drill bit and speed must be considered. This process can be used as the diameter of drill bit is matching with the hole that we want to drill. In addition, we use 3D printing. We use 3D printing to design and assemble locking mechanism and connector based on specific dimensions that have been created. It is more suitable process for creating connector and locking mechanism as the design is complex and suitable for ABS material to 3D printing. Last is sewing process. In this process, we use threads and needle to sew the fabric using waterproof nylon fabric at outer bag. We also connect the zipper polyester with outer fabric and thermal inside of the bag. That's all from me.
Hi, now I will continue presenting the cost analysis for expandable delivery bag. First is the cost of material. In this table, there are 10 different parts which are from different material and prices. There are 8 material are purchased and 2 are manufactured. So, the overall cost for the material are RM140.96. So, when we round off, it will become 141 ringgit. Next is the direct labor cost. We have 3 important roles in producing the expandable delivery bag. First is the supervisor, next the operator, and lastly the tailor. The total amount of direct labor cost is 8,100 ringgit. We give 1,200 ringgit to our operator and tailor due to the minimum wage in Malaysia. This is our manufacturing overhead cost. It is the sum of indirect material, indirect labor, and indirect expenses. So, the total manufacturing overhead cost for the expandable delivery bag is 6,113 ringgit for a month. We have fixed costs and variable costs. For fixed costs, it is the sum of direct labor costs, indirect labor costs, maintenance, building rent, and assessment tax. So when we total up, it will be 13,860 ringgit and 67 cents. For our variable costs, it is the sum of direct material costs, indirect material costs, and indirect expenses. So the total up for variable cost is 160 ringgit and 71 cents. For indirect expenses, since we targeted we will produce 400 expandable delivery bag for a month, so we divided the total indirect expenses with 400 to get the indirect expenses per unit. For manufacturing cost, we use the formula with adding the direct labor cost per unit plus direct material cost per unit plus with manufacturing overhead cost per unit. So when we add all the direct costs, it will cost 176 ringgit and 50 cents. For the manufacturing overhead cost per unit, we divided the total manufacturing overhead to 400 because we target to produce 400 bags within a month. For our selling price, it's the sum of manufacturing cost and profit margin. For our profit, we take 30% of the manufacturing cost. So when we sum up, the selling price will be 229 ringgit and 50 cents. Finally, for the break-even, the fixed cost will be divided by the value of sale price per unit minus the variable cost per unit. So after we calculate, the break-even will be 201 unit. So because of that, we need 201 unit must be sold to achieve break-even.
So here we select our material. For supporting part, there are 4 steps, which is transaction, screening, ranking, and documentation. As you can see in the table, design requirement for the hollow tube lists the 4 things that we need in our product, which the next table shows the ranking. Based on the table ranking, it shows the best product are polypropylene because it fulfills the requirement. There is no coefficient compared to others, and polypropylene has highest net score. Therefore, polypropylene is selected to make a supporting part of product. Here is the step on how we decide to choose the material. Firstly, we need to use the CAS software to analyze the material by screening. It can set the limit and we can finalize the best material. So on the specific limit, we can analyze it on yield strength, which material is the best, and it's still on the limit. Let's see the sustainability analysis for the product. So, there are 4 major components to the expandable delivery bag, which are aluminum component, plastic component, fabric component, and magnet component. Life cycle is a stage of materials goes through during its life, and all the parts are flow from a raw material and end up it's recycled or reused. Life cycle assessment is used as a tool to assess the aroma impact of the product through its life cycle, which is start from the raw material process, manufacturing process, product use, and for the last one is the end of life. Finally, here is a result of the sustainability analysis of the material. Most of the material we use for the product is polypropylene. Polypropylene is the green product because it will be recycled and also ductile. For the manufacturing, the product does not produce a high waste and it's user-friendly and forward convenient to the user.
Overall, the 3 objectives that have been achieved by analyzing and simulate the product using SolidWorks software. Then, our target users or target markets are among food delivery companies such as GrabFood, Foodpanda, Lalamove, and many more. The benefit to our delivery bag is it is more practical in terms of space because our team has developed an expandable mechanism that can adjust the bags to 3 different sizes. Next, the manufacturing cost to produce this bag is around 176 ringgit. This cost is quite high when compared to GrabFood and Foodpanda companies where they charge their riders around 150 ringgit. However, our manufacturing costs can be reduced if we purchase the raw material in bulk. So, in conclusion, our manufacturing costs can compete in the market if produced in large quantities.
Thank you for taking the time to watch our group presentation video. We apologize if there are any shortcomings in this video.